This is Higher Maths. It's the question from the past paper 2006. It's a paper 1 question, so non-calculator, it's question 10. I've been asked to show the solution to this one. If you've not tried this one yet, freeze the video and attempt this one. I'll show you the solution. Okay, let's go ahead with this one. So two variables, x and y, are connected by the law y is equal to a to the power of x. The graph of log y to the base 4, so that's going to be important to us, against x is a straight line passing through the origin, through 0, 0. And the point a, 6, 3, so 6, 3. Find the value of a. Right, so let's go ahead and do this one here. So let's write down the connection first of all. So what we have here is we've got y is equal to a to the power of x. What I'm going to do first of all is I'm going to take logs of both sides, okay? And the important thing here is I'm going to take the log to the base 4 because that's what I've been given in the graph here. So this side here, log y to the base 4, and on this side here will be log a to the power of x to the base 4. Okay? So that one there is just take the logs of both sides, okay? Right, so the next thing I'm going to do is I'm going to use the law of logs, okay? What I'll do is I'll grab that x and I'll pull it down to the front from the law of logs. Okay. Right, from there what I'm going to do is I'm going to rearrange this into the straight line form. So I'll rearrange to straight line form, and the form, remember, will be y is equal to mx plus c. So I'm going to rearrange this part to make it look more like y is equal to mx plus c. So at this side here I've not only got y, I've got log y to the base 4, and here what I've got is I've got log 4a, and that will be multiplied by x that's there. Okay, so that's it in that form already. So just to try and show what we've got here, there we go. So what I can say is that my gradient there matches up here with log a to the base 4, y matches up with log y to the base 4. I don't have any value for c, so therefore the value of c is equal to 0, and that's not really too important from here. I could get it from there or from the graph. Okay, so that would be that point there. Right, so what we'll do next is we've been given a point, and what I'll do is I'll substitute this point here, the 6, 3, into this equation here. Okay, so I'm going to substitute the point A, which is 6, 3, into the above equation. Okay, and remember what I'm subbing in is I've got an x value and I've got a log to the base 4 y value that's there because that's what's on that axis. Right, so into here I've got 3 will be here, so that's the 3 is equal to log 4 base a, and the x value is going to be 6, so it's going to be multiplied by 6 that's there. What I'll do is I'll just rearrange that to make it look a bit better for working through. Okay, so from there there's two methods that I can use to try and work this part out here. I could use the law of logs, and or I could divide it by 6. Let's divide it by 6. So from this side here I've got 3 over 6 is equal to log a to the base 4. So that'll just give me a half on this side is equal to log a to the base 4. What I'll do here is I'm going to just convert this. I'm going to convert to the exponential form. Okay, so converting to the exponential form, what I've got here is I know that a is going to be equal to the base, which is 4, to the power of that half that's there. So, and remember what that is, that's just the square root of 4. So I've got a value for a coming in at 2. So that's the way I would complete that one there. When I said that there was an alternative kind of solution for this, from here what I could have done, okay, so here's a kind of alternative. what we could have had would have been 3 is equal to log, it's our base 4, and it's going to be a to the power of 6. That will appear there. What I would then do is I could take the exponential form, and what I would have is on this side a to the power of 6 is equal to the base 4 to the power of 3. From there, a to the power of 6 is going to be equal to, so if I've got 4 times 4 times 4, that's going to give me 64, and then what I'll do is I'll take the sixth root of 64. So what number times itself, so on, 6 times will give me 64, and that's going to give me the same answer of 2. Okay. So an important thing with this question here is knowing how to change from the log form to the exponential form, or the exponential form to the log form. So just at the side here, I'll just show you what that's like. So I've got x is equal to log a y, and they could be values that are in there. What I'd be wanting to do is to change that in one direction, and that would be to the exponential form. And if I do that, what I'm going to do is I'm going to take whatever sitting number is sitting here or letter, so that's going to be y is equal to, and the base here is going to stay the base here, so whatever number's there, that will be an a, and it will be to the power of whatever's left on that side there, so that's that there. Or if I wanted to transfer it back into log form, I would go back in that direction there. So that's a simple way that I would convert these, so that would be to log form in that direction, exponential form in that direction. So that's just a little bit of information that may be a bit helpful for you there as well. Okay, marking for this one here. So let's go for it. We'll go for 1 mark for taking the logs of both sides. So we'll go for that one there. Next mark I'm going to get will be for getting to this stage here, and that's really about substituting the points into the equation that we have there. On the official marking scheme, the official marking scheme would give a mark over here. Okay, so it would be that one there, and it would give you a mark for 2. Okay, so that would be the official marking scheme there. If I was doing it myself, I would be working it down this route here, and I'd gain 2 marks from that point to that point there. So total of this question out of 4 marks, and hopefully this has helped you.